Okay, so today's lesson we are building on the previous lesson about learning about the quadratic formula. And there is a special part of the quadratic formula, and let me rewrite the quadratic formula so we can see it as I'm talking about it. Plus or minus, and then under the square root, I'm going to write this in purple so it's very clear what I'm talking about. 2a. So that part that I wrote in purple there, we call that the discriminant, all right? That b squared minus 4ac, all right? Just the stuff under the square root. So the square root is not included in what we call the discriminant. And the reason this is a very special portion of the quadratic formula is because in math, when we take the square root of a negative number, so let's say I'd ask you to take the square root of -2, you would not be able to do that. So in the previous lesson, we learned what the quadratic formula tells us. It tells us how many, or it calculates the roots, right? It actually gives us what the intercepts are. But if this whole portion right here, the discriminant, works out to be negative, can you evaluate the square root? Well, no, you wouldn't. So then if it's x equals, like if you're solving for the x-intercepts, but you can't actually solve it because there's a negative under the square root, you wouldn't have any roots. You wouldn't have any x-intercepts, okay? So the discriminant is a very quick way for us to say, well, actually, how many solutions do we have in this problem? So let's go through this chart and we'll just see how the discriminant, so this column right here, is calculating the discriminant. A horrible speller, discriminant. There we go, I hope I spelled it right, yep. Discriminant. And so we'll apply to all these different quadratics here and we'll just see how it plays out. So the first one, we have y equals x squared plus 2x minus 9. It's asking us how many number of zeros there are. Well, we can see right here and here, just by quickly looking at the graph. There's 2 zeros. All right, let's calculate what those zeros actually are using the quadratic formula. So we have a in this formula would be 1, b, again, just looking right over here, so b is 2, c is minus 9. So just plug them in. So using this formula right up above, so x equals minus 2 plus or minus 4, or 2 squared, minus 4, a is 1, c is minus 9, all over, sorry, it's a minus 9, all over 2 times 1. So x equals minus 2 plus or minus, well, under the square root, we have 4 minus 4 times 1 times -9, so that would be 4 plus 36, or the square root of 40. Didn't really need that big of a square root then. And then divide that by 2. So square root 40 is not a square, so you are going to get a decimal. So take out your calculator. So we have -2 plus or minus, and let's evaluate what square root 40 is. And go to 2 decimal places, that's more than enough. So 6, 3, 2, all over 2. So again, as in previous lesson, this plus or minus right here, in front of that square root there, that's what allows us to get 2 roots. So you have the first x-intercept, x equal x1, where you would do the positive version of it, so it'd be -2 plus 6.32 all over 2. And again, doing that, just use your calculator. So minus 2, divide that by 2. You would have an x-intercept of 2.16. And just pausing for a second, does that make sense? Well, yeah, that right there, that's probably x equals, or has an x coordinate, so I should put it in coordinate form, 2.16 comma 0. That's what that is right there. That's what you just found. All right, and then you have your other one where you do the subtraction version of it. So you would have your other x-intercept, and just again, use logic, just be like, okay, well, you know, you can kind of see that's between -4 and -5, so you probably think it'd be like -4.2 something, right? Well, let's see. So we have x2, is minus 2, minus version of it, 6.32 all over 2. And again, use a calculator, so negative 2 minus 6.32, divide that by 2. That's pretty close to my estimate, 4.16. So there are your two solutions, right? The x coordinates. Well, again, the discriminant doesn't tell us what the actual roots are, okay? So the quadratic formula tells you this point. So that is at the point 4.16, 0. This is at the point 2.16, comma 0. But if I ask you a question, how many roots are there? Well, you would say you calculate this. So using your b value, which we have is b was 2, a was 1, and c was negative 9, just from the problem right here. Plug them into that formula, which is just the part under the square root. And we already evaluated the square root. It's right here. So b squared minus 4ac, plugging in those numbers in, 4, 1, minus 9, we get 40. Okay? So we'll come back to this in a second and what the significance of this being specifically a positive. Actually, you know what? I'm going to say right now. Because this is a positive number, notice how we were able to evaluate the root. We were able to evaluate right here. And that's at that step, we were then able to get two solutions, okay? So the fact that the discriminant was a positive allowed us to evaluate the root, which gave us two solutions. Okay, let's keep going. Let's do the same process here. This one might be a little trickier, but how many zeros do we have here? Well, you can see the parabola would come down like this. You have your vertex right here, and then going up. So this one actually only has one solution, 1, 0. Let's calculate using what that 0 is, right? And visually, we know that it's 3, 0. But let's see what the quadratic formula gives us. So a is 2, b is minus 12, and c is 18, just taking from the formula that we see on the left-hand side there. So we have our x-intercepts are going to be minus negative 12, careful with the negatives, plus or minus 12 squared, minus 4, a is 2, c is 18, all over 2 times 2. All right, so we get x equals, and then negative 12 times negative 12, that's actually ends up just being 12, plus or minus, well, negative 12 squared is 144, and then minus 4 times 2 is 8, and then 8 times 18, oh sorry, is that, yeah, that's 18. So we have 8 times 18, which should be minus 144. And then we divide all of that by 4. Okay, well notice what's going to happen underneath the square root now. We are going to get 12 plus or minus the square root. 144 take away 144 is 0. So then divide that by 4. Well, the square root of 0 is just 0. Because 0 times 0 gives you 0. So when you're taking the square root of something, you're asking you what same two numbers multiply to give you what's under the square root. So square root of 0 is 0. So x equals 12. Well, plus or minus 0, like, do I even have this plus or minus here? Because if I have $12, for example, and I add $0, does anything change? Or if I have $12 and I take away $0, again, does anything change? Well, no. So in reality, because there's that 0 under the root, you really don't even need that plus or minus. So you just get 12 over 4, which then calculates to 3. And notice, like in contrast to the previous problem, when we had that plus or minus, we had to do these arrows right here on the step and go down 2 different solutions. But because we have a 0 under the square root, there's only one path you go down. You get rid of that plus or minus. So we only had one solution. So again, a solution would be an x-intercept only at 3, 0. And visually, we see that. There's only one point where you intersect the x-axis at 3, 0. Well, if you were to ask this question and say how many zeros would you have, you would calculate your discriminant. So you would do b squared minus 4ac. So plugging in your numbers, you would get minus 12 squared minus 4 to 18. And calculating all that, so again, proper equals, that would be 144 minus 144, we just did the math, and you would get, 0, all right? It would equal 0. So equals 0. So notice in the previous problem, when the discriminant was positive, 2 solutions. When the discriminant was 0, you had one solution. All right, let's do the last problem. How many intercepts do we have here? And remember, on a quadratic, these are like arrows right up here. So these arrows indicate that the graph is going to keep going up and up. It's never going to turn around and come back down, okay? So because it's going up and up and up forever, and you can clearly see that this is your lowest point right here, and the x-axis is all the way down here, well, this has 0 solutions. There are no x-intercepts. And just to make it clear, let's rewrite this formula in standard form. Well, it is in standard form already, but let's just make it more obvious. That would be 3x squared plus 0x, all right, because you don't see that middle term there. It is technically being multiplied by 0, plus 4. So we have an a of 3, a b of 0, and a c of 4. Let's use our quadratic formula. X equals negative b, so negative 0, plus or minus b squared, which would be 0 squared, minus 4, 3, and 4. All over 2 times 3. So we get x equals, well, negative 0 doesn't do anything, so it actually just ends up being plus or minus the square root of 0 squared minus 4 times 3 times 4, so that would be minus 48, all over 6. Well, I have a negative under the square root. So I can't do this. I like check your calculator. You can't go any forward. So you're going to get an error. So that means, therefore, no solution. Or, as we just said right here, no x-intercepts. And mathematically, if you're using the discriminant, b squared minus 4ac, well, b would be 0 squared, minus 4, a would be 3, 4, so equals, well, that'd be 0 minus 48 again, equals minus 48. Well, now we have a negative number, and our discriminant worked out to be a negative. And again, notice what happened. You had an error. So we had 3 different scenarios. Where the discriminant was positive in the first one, you had 2 zeros. Discriminant was 0 in our second example. We got 1 solution. And then in the last one, because you can't take the square root of a negative, and that's what the discriminant being negative means, can't take the square root of it, you're not going to be able to evaluate, so you'll have 0 solutions. So that's what this next one is asking us right here. two real roots. So two real roots, again, roots is just another way of saying you have two x-intercepts or two solutions. Well, what was the condition of the quadratic that gave us two roots? Well, it was when the discriminant was positive, i.e., when b squared minus 4ac had a value that was bigger than 0. It is positive. All right. Well, one real root. Go back up. What was the scenario where we had one x-intercept? Well, that was the second one. And that happened when you had a 0 under the square root. Okay? So here, the discriminant, the thing under the square root, was equal to 0. Or b squared minus 4ac equals 0. If that evaluates having 0, you have only one solution. The biggest mistake is that people calculate a 0 under the discriminant and they think that means no solutions because they think 0 means nothing. No, 0 just means that the square root didn't have any impact, meaning that whole plus or minus had no impact. So really, it's that plus or minus that we're really after here. Okay, and then the last one, no real roots. Well, that was our last scenario here, and that was when the discriminant was negative. Discriminant is negative. And that's just when the b squared minus 4ac term is less than 0, okay? Negative number. So you're either in one of these three camps when we're dealing with quadratics, okay? Bigger than 0, equal to 0, or less than 0. So let's do an example. Write the discriminant in each of the following equations and determine the number of real solutions of each equation. Key thing, do not solve, okay? So I don't actually care what the value of the x-intercepts is. So you're not telling me x equals 3, like there's an x-intercept at 3. No. Just tell me, if you were to solve, how many solutions would you get? Would you get 2, 1, or none? Okay, that's what we're after here. So in this first problem right here, this is not in standard form. So get this into standard form. We need it in standard form to do the quadratic. So first step, write in standard. And this is given to us in vertex form. So it means we need to expand, okay? So expanding this out is minus 2, x minus 1, x minus 1, plus 5 equals 0. All right, well, now we need to distribute and clean up our brackets. And again, this is now old content, so I'm just going to write it. Oh, I shouldn't have two equal signs here. That's poor communication. So minus 2, x squared, minus 2x, plus 1, plus 5, after you expand that bracket. And then you get minus 2x squared, plus 4x, minus 2, plus 5. And then minus 2x squared plus 4x plus 3, okay? So now we have our standard form. Here our a is minus 2, our b is 4, and our c is 3. So using the discriminant, so the discriminant would be b squared minus 4ac, which is just the part under the square root. Well, what do we get? 4 squared minus 4 minus 2, 3. 16, equals 16 minus, so what would that be? No, minus 4 times negative 2 is 8. 8 times 3 is 24. And that's positive because it's two negative, that'd be positive, yep. So equals, well, 16 plus 24 is 30. Actually, why am I equals on that side? It should be equals 30. 40. Well, again, that 40 is not an x-intercept. So does not mean, I'm just going to make this very clear, does not mean x-intercept at 40. No, what that means is that this number is positive. So therefore, our discriminant is bigger than 0. It is positive. So 2 real roots or solutions. You can use whatever word you want, okay? Well, let's do the next one. Get this into standard form, okay? So we need to bring this over and this over. So 3x squared plus 4x minus 7x when we bring it over to the other side. And then that negative 5 becomes positive 5. So that's 3x squared minus 3x plus 5 equals 0. All right, and again, you can see that we have an a of 3 now, a b of minus 3, and a c of 5. Plug those into your discriminant formula. So discriminant is equal to b squared minus 4ac. So that would be minus 3 squared, keep in mind your brackets, minus 4, 3, 5. So that's 9 minus 12 times 5. I'll just break that math up. Well, that's 9 minus, well, what's 12 times 5? 60. So minus 51. Well, we have a negative discriminant. So again, that means if you were to actually use your quadratic formula, it would be minus b plus or minus. You would have a negative 51 here. That's what that means, all right? Well, you can't evaluate this because you have a negative under the square root. So meaning you will have, so therefore, no real roots since discriminant is less than 0. Negative, okay? You can write negative there. I just use that symbol. And when you get used to using these less than symbols. Okay, let's keep going. So without graphing, determine whether each quadratic function intersects the x-axis at 1 point, 2 points, or not at all. Well, this is essentially just asking the same thing above. How many roots are there, right? It's just using those different terminologies. So you're determining how many times the function intersects the x-axis, i.e., so this part right here, this is just saying how many number of real roots or number of solutions, okay? Again, just knowing how they're just put it in different words. So at 1 point, meaning do you only have one x-intercept? Or one real root? Real root. And that would happen when the d is equal to 0, the discriminant is equal to 0. Do we have 2 points? All right, well that would happen when the discriminant is bigger than 0 or none at all. Well, this would happen when the discriminant is less than 0 because it'd be negative number to the square root. So these questions are pretty quick, okay, once you get the hang of it. So the discriminant, just calculate it. Well, it's b squared minus 4ac. And just looking up here, here's a, b, c. So we have 3 squared minus 4, 2, minus 5. So that's 9 minus 8 times minus 5, which would be 9 plus 40, which would be 49. So therefore, right, and again, this is really all you have to say. You calculate it. So you show me your knowledge, and you can see that this is a positive number. So you would say, therefore, and using the wording in this question, intersects x-axis. Therefore, intersects the x-axis twice, or 2 solutions, because the discriminant is positive. You'd have a positive under the square root. So, next one. Again, I'm giving you this in vertex form, so let's put it into standard form. We need to know our A, our B, and our C. So this is rewritten as y is minus 2, minus 2, minus 3. Y is minus 2, x squared minus 4x plus 4 minus 3. Y is minus 2 x squared plus 8x minus 8 minus 3. And then in standard form, just collect your last terms, minus 11. All right, I just cleaned up this last one right here. All right, so there's the standard form. Just calculate discriminant. And really, that's just how I can make these questions a little harder. Really just testing you, do you understand it? Because I'm not giving you any A, B, or C's here. I'm giving it to you in vertex form. So we have our discriminant, b squared minus 4ac. I'll do it in blue. AC. Well, our b in this case is 8 squared minus 4. A is minus 2 minus 11. So 64. Well, negative 4 times negative 2 times negative 11. That's 3 negatives being multiplied. So we will get a negative number here. So that's 88. Okay, that makes 8. And then 8 times 11 is 88. Well, this is a bigger number. So this is, what, minus 24. So because we have a negative discriminant, therefore, no x-intercepts. All right, it does not intersect the x-axis. So it has 0 x-intercepts. All right, determine the value of k such that the quadratic function f of x equals negative x squared plus kx minus 27, and it only has one real root. I love these types of questions. This really tells me if you understand the problem. So I'm telling you it has one real root. What that whenever you see that wording, if I tell you how many solutions there are, this means, this whole part right here tells you that the discriminant is equal to 0, because the only way you get one root is when you have a 0 under the square root. So that means b squared minus 4ac has to equal 0. Well, if I'm giving you the equation, y is minus x squared plus kx minus 27. Here, our a is negative 1. That k is our b value. So b is technically k. That's our unknown and we're looking for it. And c is equal to minus 27. So plug that into your discriminant formula. So our discriminant is b squared, which would end up being k squared, minus 4. Our a is minus 1. Our c is minus 27. It's all equal to 0, because again, it's equal to 0. We only want one solution. So then you get k squared minus 4 times negative 1 times negative 27. Well, I need to use my calculator for this. That would be 108, all right? But again, 3 negatives, it would be minus 108. All right, well now k squared, bring the 108 over, so 108. Well then k is the square root of both sides. So then what is the square root of 108? It would be, and again, there is a plus or minus here in front of the square root. So k can either be plus or minus 10.39, okay? So not really a clean number, but that would be a solution. So hypothetically, you would see an equation, and really we shouldn't leave this in decimal format, but I'll put it in for the sake of this. This would be y equals minus x squared, right? Because you're just rewriting this and replacing the k. And then it would be, you can either use the plus 10.39x minus 27, or it could be y is minus x squared minus 10.39x minus 27. Both of those would be a valid solution or a valid quadratic equation that would result in only having one solution, okay? All right, and there is the work for class. I'll see you then.